Okay, good morning everyone. I am Anthony from the Health Science at Brindabella Christian College. I am here to demonstrate as part of your assignment, an assignment for my year 12 chemistry students about determining the mass of copper in brass. So it's a redox titration that we are trying to demonstrate here. My students were supposed to be doing this as part of their investigative track. However, since in the current COVID-19 scenario that we have, you're unfortunately not going to be able to do it. So I'll demonstrate it for you. For doing this determination, you have thiosulfate, and you're going to use potassium iodide as the primary standard used to standardize that thiosulfate. Now, before you start all that, as you know, we are still trying to determine copper in brass. So we've taken around 2 grams of brass nails, and this brass nails, if it contains copper. Now this copper, we can't find out how much of copper is there in this. We need to take it out into solution if you need to do a titration. So to do that, we react it with an oxidizing agent like nitric acid. As you know, nitric acid is a powerful oxidizing agent. It's very harmful for an inhalation, is going to cause severe breathing problems. We added 20 ml of concentrated nitric acid to the brass nails. This was just so that we can get that copper inside the nails into solution. Because if you don't have it in solution, we're not going to be able to determine it. And if you don't determine how much copper ions are there, we can't find out what is the percentage of copper in brass. So let's move on. And as we know, the titrant that we're using is sodium thiosulfate. This thiosulfate has to be standardized. To do that, we are using potassium iodide as our primary standard. So we've got our potassium iodide ready to go, a 1 molar solution. We need to do this in acidic medium, so we have got 1 molar sodium sulfuric acid. We need an oxidizing agent, which is your hydrogen peroxide. The method would suggest you add 3 ml of the potassium iodide, 3 ml of the acid, and they would say a few drops of peroxide. Why I do those things, I need you to tell me in your report. As you know, while you're doing your quantitative analysis, you need to make sure that all your equipment are clean and they have to be rinsed with the solution that you're taking. So we're starting off with potassium iodide. I need a quantitative amount of it, hence I'm using the pipette. So now we have taken 2 alcohols of potassium iodide. This potassium iodide is a 1 molar solution. Now we need to add exactly the same amount of sulfuric acid. Again, we follow the same procedure. Remember, the sulfuric acid provides that acidic medium that helps in this redox reaction to proceed. Once that's done, the reaction hasn't begun. The reaction will not begin till you add your peroxide to it. Now this is a 6% peroxide. The method suggests about a few drops of it. And I will add only in one, because what is happening here is iodine, or the potassium iodide, is undergoing redox reaction there. So it's starting at 0. So that's your initial burette reading. You record it in your book. Once that's done, then you begin your titration. So we are looking for a pale yellow color. So all the iodine that is being released is going to react with the thiosulfate. And since we already know the concentration of potassium iodide, that gives us the concentration of iodine. And if we know the concentration of iodine, or the number of moles of iodine, then from that we can actually deduce the number of moles of sodium thiosulfate. And that's how we standardize sodium thiosulfate. The reason that I have used a mask is because, not just because of COVID-19, it's also because of the iodine that is being released. We don't want too much inhalation of the same thing. We need a pale yellow color before we add the starch. This might be a good time for me to actually start adding some distilled water to ensure that all the droplets of thiosulfate that might be sticking to the sides are going in. I think I'm feeling fairly confident the end point is close. So what I'm going to do is I'm going to add my starch solution. So I'm going to add 2 ml of the starch solution. Yep. You can see that violet color. Your end point is when that turns into pale white. Okay, we got our end point there. So that just means that give you a title value of what? It's 38.6 mils. Let's just write that here so we have it. As you can see, it's taking around 38.6 mils. I'll have to refill my thiosulfate if I need to do the next titration. So again, the burette reading is beginning at 0, and now we need to prepare our second batch. We already know that it's going to be around 38 mils, so we'll just take care of that. So you can see that's our potassium iodide with sulfuric acid. Now we are going to add our 1 ml of hydrogen peroxide to it. And there we go, the reaction has begun. And we need to start this again. This time we have a rough idea where the title value is going to be, so we'll just let it loose for the first 30 mils or so. That is not expected. It's only 26 mils and it's already So let's just add the starch now and see if that's going to help. This is the beauty of parametric titration. Just doesn't want to. Alright, so we got our beautiful starch solving everything. Let's see where this goes. And that is my endpoint. So, what is our titer reading now? I'm going to say it is 32.0. Obviously, we haven't got it within a mil, so we have to redo this. So we're starting at 0. Being very mindful that this iodine being released here. Okay, so it's getting nearly that pale yellow color. So we add our starch solution to it now. Adding the exact same amount of your starch solution again. So it's around 2 mils. That's the method is suggesting. Rinse out the excess. Make sure I rinse the tip of the burette as well. And then we start. Shouldn't be long. It's just that something more oxidizing is just getting into it. Okay. That's an endpoint for us there. So that comes to 29.1 mil, 29.1 mil. So that's because we had to change the solution, we had to redo both the experiments. Now we need to do the second one. That's about there. Yes, and that's our endpoint. And that comes to around 9.2 mils. Alright, so now we need to transfer the copper solution from here into our standard flask, make it up to volume. So we have captured all the copper that is there in that nails. And this has to be done quantitatively. Quantitatively in the sense that every little drop of this have to go into our standard flask. To do that, we carefully transfer it. Quantitative transfer means we continue to wash the beaker with little amounts of water. This is just so that I get everything out, every little speck out. We don't need to lose even a drop. Because a drop, if you think of it in percentage level, is going to account for a huge loss. The next part is making it up to volume, making it up to the mark that is given over there. You can just allow it to go as quickly as you want. And yes, got it. I've got it to the mince this. Now we are just going to make sure that it's well mixed. all of the copper in the brass nail has been dissolved, quantitatively transferred. Now what we have to do is take out 25 mils of this solution into 2 conical flasks, because we need to do any analysis in duplicates, and then do a little magic on it and then titrate. We have added 25 mils of copper solution into our conical flask. Now what we need to do is, because it's too acidic, we have added concentrated nitric acid to it. Even though we have diluted it now by making it up to 250 mils, it is still a bit too acidic. So we need to bring the pH up slightly. So to do that, we use sodium carbonate, a molar solution of sodium carbonate. That's the method's suggestion, and we'll do it dropwise till we find a precipitate of the carbonate coming out. So we take our sodium carbonate, we're going to see, as we add, we can see some precipitate formation, but we need that precipitate to stay for some time. It has become cloudy, and if I add a bit more, I can see that it still stays. It is not dissolving. So this tells me nitric acid has been almost neutralized. Now what you do is, we just need to add a few drops of our acid so that it's slightly acidic. The turbidity is gone, and now the solution is slightly acidic. Add your 10 ml of potassium iodide. So let's start our titration again. Again, we have around a 0.1 molar solution of thiosulfate with us. We're going to titrate it against the iodine that is being released, and we'll see how we go. Going to add our starch now. We'll drop, nearly there, and we are there, and we are there. So now this is not standardization of thiosulfate anymore, it is determination of copper in brass. The main aim of this titration would be finding out concentration of the copper ions in solution. So this is the question for you, and let's start this again. Yay! And we got 20.4 mils. So you average it out and take it. So hope that's useful, and hope you do a good job on your report. Thank you guys.